Okay, so this is my summary of questions that we did in the lecture and lectural in the last session. We also did some other quizzes and things like that, but this is the focus for the exam, really. So we're going to do a long type of question, I think. So this could be a bit like a section B type question. Now, those questions start usually with maybe some kind of proof of reactions here. So this particular one, we've got to prove these red values are created by the green values. So everything's given to you. You just got to show the mass, really. So we're going to define a reaction here as our RAX, a reaction here as my RAY, and we're going to have a reaction here, my REY. So the question will be for you to then prove these numbers. Notice we got, watch out, we've got an RAY, which is a negative reaction. So give that a go, and when you're ready, I will have a crack at it, show you what I would do. So for this problem, see, we need to ignore these numbers for the moment. So let's put in our RAX here, RAY. Need to ignore this and replace it with an REY. I'd be tempted with frameworks always just to take moments at the two particular pivot points. You could take moments at the hinge, it's what is normally done in the course notes, and then resolve forces in the y direction with the other one. It's probably best not to, but to use the resolve forces in the y direction as a check. Anyway, so let's crack on. So we'll resolve moments and we'll start at the joint A. Going to go around in that direction. So that will take out these two unknowns. The distance away from them is 0. First one we look at is this one up here. So we need to make a right angle above that pivot. So there's my right angle. So I'm going to imagine that force flies back to this position here, then measure the distance from here to here. That's 4 meters. It's going to go around in the clockwise sense, so it's 60 times 4. This one, again, I need to make it fly so it's either horizontal or vertical with the pivot. So I'm going to make it come down to this position here. And so now it's, it's coming downwards. Isn't it? So the distance from here to here is 9 meters and it's coming downwards. The actual force is coming downwards here. So it's creating a we're going around this sense, so it's creating a positive clockwise moment, so that'd be plus 40 times 9, and this REY would be going upwards, so 6, 12, we would be going upwards, so we're going in the opposite sense, minus 12 REY 0. Okay, so let's just rearrange that. That gives me REY equals, I'm just going to let my calculator do the work, 60 times 4 plus 40 times 9 and divide by 12. So I'm just going to stick all of that into my calculator. 60 times 4 plus 40 times 9 divide by 12, and it gives me 50 kilonewtons. So that agrees with my first result I need to prove. So the next one, I'll take moments, and I'm going to take moments at E. I'm going to go clockwise again. So we're at this point here, we'll go clockwise. So when we get to this force here, we bring it back down to this position here, measure it. Notice it's going in the opposite sense to where the clock wants to turn. So it's a negative moment, minus 40. Distance away from here to here is going to be 3. This one here, we're going to fly all the way over. So it's vertically above. It's at this point here, so the force is doing this. And again, it's 4 meters away. It's going clockwise, so it's plus 60 times 4. Right, now the RAX goes straight through the pivot, so it doesn't create a moment. The RAY is going upwards, and that's going upwards too, so it's both positive, so plus. How far away is it? 6, 12 equals 0. So that gives me RAY, move these things over to the right hand side, is 40 times 3, take away 60 times 4, let the calculator do the work, divided by 12 equals, so 40 times 3, take away 60 times 4, divided by 12, gives me minus 10. And so this 10 is pointing downwards, so it's a minus in my convention, as it were. So the next thing you could do would be, you could do a check, sum up your forces in the y direction. So we've got the minus 10, the plus 50, and we got the 40 coming downwards, minus 40, and we can see that equals 0, so check works. Okay, so then finally we want to find the reaction of RAX. So to solve that one, I will sum up forces in the x direction. So I've got an RAX, ignoring the 60 here, got the 60 there, equals 0. Can't see any other forces going left to right. So therefore RAX equals minus 60. And again, this, at this hinge, we've got the force going from right to left, so it's a negative. So again, that one works. So that would be the way to start a question. And to make it a proof, obviously it helps you, but it also means that you can then use the results from this framework as a follow-on to the next question. Finally, obviously you can't do this in the exam, but you can have a look at the result if you use something like MD Solids, and that will tell you what all the various members should have, and also we can see the reactions here, can't we? So MD Solids shows us the reactions for our current loading. Okay, so everything looks good. 10 going downwards, 60 going right to left, 50 going upwards.